If you could get back in a time machine and go back to geometry class, whatever year you had that, I bet you would be able to go back to a lesson your geometry teacher taught you about a 30, 60, 90 right triangle. And it would look something like this. If you have a right triangle where with a 30-degree angle here and a 60-degree angle here, then if the hypotenuse is 1 unit long, this opposite side is always going to be half of that. The side opposite of the 30-degree angle is going to be half of that. And then the adjacent side to the 30 is actually going to be radical 3 over 2 compared to the hypotenuse. Now, I'm going to introduce you to something called the unit circle today. What somebody did when trigonometry was first formed, what somebody did is they said, let's imagine a circle that has a radius of 1. And I'm going to draw this as best as I can. I'm sure it will be lovely. That actually wasn't too bad. So imagine a big circle that has a radius of 1. I know that if this was the origin, if I made the center of the circle the origin at 0, 0, then I know that this point right here would have the coordinates radical 3 over 2, 1/2. What that person was able to do is take an entire, a large kind of unit circle here and say at a 30-degree angle, or as radians, you could say it's pi over 6 radians. The coordinates at this point would be radical 3 over 2, 1/2. And see, if you change that then, if you were to make this angle 60 degrees, that actually gets flipped. You'd have a 1/2 here and a radical 3 over 2. Well, I want you to realize this was kind of like the birthplace of trigonometry, is taking these 30, 60, 90 triangles and kind of graphing them out on a big coordinate plane, where you have the circle, the middle of the circle is always the origin at 0, 0, and then the hypotenuse, this length here, is always 1. That would also put some of your key points like over here at 1, 0, and up here at 0, 1, and over here at -1, 0, and down here at 0, -1. Now I'm not going to bore you by filling in all of these details. If you go to your assignment today, the very last page has a unit circle that's already been filled in for you. But I just want to give you kind of a little idea of where this all came from. This all originated from the idea of a 30, 60, 90 triangle. And then also you'll notice it also originates, there's another type of triangle called a 45, 45, 90 triangle. And those are placed in as well. See, once you know the coordinates for this 30-degree angle, you can flip it to the other side as well and find what it would be for 150 degrees or for 120 degrees. Really, any multiple of 30 or any multiple of 45, you could find those coordinates. Okay, so that's my brief little introduction to the unit circle. And actually, before we dig into your homework, some really important notes that I highly recommend that you write these down. You could write them like on the back of your unit circle. This will help a ton. You can make some generalizations with the unit circle. So anytime you see the x-coordinate on your unit circle, that always represents the adjacent leg of the triangle. That would be inside of that circle. So anytime you see this x-coordinate, think about it, that represents the leg that's adjacent to the 30-degree angle. Okay, so always think of x as adjacent. Likewise, anytime we see a y-coordinate, we could always think of that as the length of the opposite leg of that triangle. Okay, and then of course with the unit circle, the hypotenuse is always equal to 1. So with that in mind, we can really simplify, we can kind of rewrite all of our main trig functions that we know. So the sine of theta is opposite over hypotenuse. Well, we can write that as y over 1, or just simplify it to y. If we need to find the sine of a particular angle, we can just look at its y-coordinate on the unit circle. And you know what? Let's go ahead and fill out for the rest of these. Let me snap my fingers here. There we go. Definitely take the time to write all of these down. It will make your life so much easier. These are all of the trig functions simplified, rewritten as kind of as ratios of x and y and 1 in simplest forms. Okay, so let's hop into our homework It should be, I don't think this is too bad when you have these notes. And as a matter of fact, here is assignment 4.6. I'm going to do every single even problem with you to help you get the hang of this. So for sine of 300 degrees, first of all, I'm going to look at my formulas, and sine is just represented by the y-coordinate. So I need to go to find 300 degrees on my unit circle and identify the y-coordinate. It can't be much easier than that. At 300 degrees, the y-coordinate is negative radical 3 over 2. That's it. Negative radical 3 over 2 is my y-coordinate, so that's my answer. If you really want to write down the point for each angle, you could. At 300 degrees, the entire point is 1/2 common negative radical 3 over 2. But remember, sine is just given by the y-coordinates. This is all I need. All right, so let's go to number 4. Number 4, the cosine of negative 210 degrees. Now, the first thing you'll notice, negative 210 degrees is not on my unit circle. So I have to go back to my last lesson, and I have to find an angle that's coterminal to 210 degrees. I'm going to add 360 degrees to this. It comes out to 150 degrees. And I'm actually going to I'm going to now find the cosine of 150 degrees, because since these angles are coterminal, 150 degrees should have the same cosine value. At 150 degrees, my coordinates are right here, negative radical 3 over 2 and positive 1 over 2. Well, remember, cosine, if I look back to my formula, cosine is given by simply looking at the x-coordinate. I got a lot of paper shuffling around here, but all I need to look for cosine is the x value. So my answer is negative radical 3 over 2, once again. Now, if it's in radians, don't be intimidated. Pi over 2. Remember, sine is just given by the x-coordinate. That's what I'm going to look for. But I'm going to look at my unit circle for pi over 2 radians. That is right here. And the coordinates are simply 0, 1. And since sine is just given by the x-coordinate, I'm sorry. Oh, I said that wrong. I'm sorry. Oh, please forgive me. I'm glad I didn't mess that up. Sine is actually given by the y-coordinate. So my answer is simply this 1. Okay, plugging along. Let's look at number 8. The tangent of 60 degrees. Now, tangent, remember, if we reference back to these notes, tangent is y over x. So I'm going to write that down. And then I need to go to 60 degrees on my unit circle and identify the coordinates. At 60 degrees, my coordinates are 1/2 and radical 3 over 2. So I have radical 3 over 2 all over 1/2. Now here, once you start getting into the tangents and the secants and cosecants and cotangents of the world, you're going to have to remember how to simplify fractions. So anytime you're dividing two fractions, radical 3 over 2 divided by 1/2, the rule is you're going to multiply the first fraction by the reciprocal of the second fraction. This can be rewritten as radical 3 over 2 times 2 over 1. Now, luckily, these 2's will cancel out. I'm left with radical 3 over 1, which is simply radical 3. So we are going to have to do some simplifying of fractions here. That's going to be your trickiest part. But the answer to this one is radical 3. Tangent of 300 degrees. Remember, tangent is y over x. So let's find 300 degrees on my unit circle. Okay, my coordinates are right here, 1/2 and negative radical 3 over 2. 1/2 common negative radical 3 over 2. So I need to find y over x. Negative radical 3 over 2. Write it right here. Negative radical 3 over 2 all over 1/2. When you divide two fractions, you keep the first fraction the same, but then you multiply by the reciprocal of the second. Now, luckily for me here, my 2's are going to cancel out. Negative radical 3 over 1 is just negative radical 3. So that is my answer to 10. All right, 12 and 14, we get into these, they're called reciprocal ratios. The 12 is the secant. So let's identify the secant. Secant is 1 over x. Now here, they're not being nice to me. I need to find this in radians here. You know what? You're allowed to convert this. If you do not want to deal with radians, another option you have is we can just say degrees is radians times 180 over pi. And my pi's cancel out. I'm going to do negative 3 times 180 divided by 4. And that comes out to, let me do that real quick. That comes out to negative 135. So if you want, we can just change this. We're finding the secant of negative 135 degrees. Now I'm going to add 360 to that to find its coterminal. Add 360 to that number. That comes out to 225. So to simplify this, it's going to be a lot easier if we say, let's find the secant of 225 degrees. Because 225 is very easy to find on the unit circle. Radical 2 over 2, and I'm sorry, negative radical 2 over 2, comma negative radical 2 over 2. Now, I need to now do 1 over x. So here's my x coordinate. I need to take 1 over negative radical 2 over 2. Now, when you divide by a fraction, the rule is you keep the numerator the same, and then you multiply it by the reciprocal of the bottom fraction. So I'm going to times it by 2 over negative radical 2. And so my answer is negative 2 over radical 2. Now I took a little time out here because this actually, so here's our answer. It gets a little tricky to simplify. So technically, I would accept this as your answer. However, there's a rule that says you're never supposed to leave a radical in the bottom of a fraction. And so let me show you the little trick here to write it the proper way. Whenever you have a fraction and there's a radical in the denominator, the rule is you're going to multiply the top and the bottom of that fraction by whatever this radical is, this radical 2. So our top becomes negative 2 radical 2. But then our bottom, remember when you take radical 2 times radical 2, it actually just turns into a normal 2. Our 2's cancel. We finally get our final answer, negative radical 2. That was quite the problem there. I kind of forgot that problem was on there, but that's it. That's how we would find it, negative radical 2. All right, I have a feeling 14 is going to be a little bit easier. So 14, we have to find the cosecant of negative 180. Let's remind ourselves what cosecant is. Cosecant is 1 over y. Now, negative 180 degrees, I'm going to find its coterminal. Well, if you add 360 to that, the coterminal just comes out to positive 180 degrees. So I can rewrite this. I'm trying to find the cosecant of positive 180 degrees. Well, 180 degrees on the unit circle, it has very simple coordinates, negative 1, comma 0. And my cosecant, the formula is 1 over y. So I'm simply going to take 1 over 0. Now, I don't know if you remember, if you ever try to divide something by 0, 1 divided by 0, that's an error. Whoops. 1 divided by 0, you're not allowed to do it. That is called an undefined answer. It's impossible to divide by 0. So that problem is undefined. All right, so those were all of the even problems for you. I hope that helped. Best of luck as you do the odds on your own, and let me know if you need any help. Take care. Bye.